basics of power and polynomial functions. And let's start with a power function. A power function is anything of this form f of x equal to k times x to the p, where k can be any real number and p is any whole number. These functions get the name power function because the variable is raised to some known power. It is important to note that our x variable should be the base of the exponent for the power function. It should be the thing we're raising to the power. The number k is known as the coefficient of the power function. The number p is known as the degree of the power function. So let's look at some examples of this. Here are several different examples of power functions, and for each one I want to figure out what is the coefficient and what is the degree. For the first one, 3x to the fourth. 3 is the number out front, so it would be the coefficient, and 4 is the exponent, so it would be the degree. For negative x to the sixth, the coefficient would be the number in front. Here we just have a negative sign. That tells us that the coefficient is negative 1. And the degree would be the exponent, or 6. Next, we have 2x to the seventh. In that case, the coefficient would be 2, and the degree would be 7. For the power function 5x, my coefficient would be 5. When we see an x without an exponent, that means the degree is 1, so the degree here would be 1. Finally, for x cubed, when we don't see any coefficient, that's the indication that the coefficient is 1, and in this case my exponent is 3, so that is the degree. So now we have found all of the coefficients and degrees of these particular power functions. Next, let's look at polynomial functions. Polynomial functions are the result of just adding together several different power functions. This definition looks a little more complicated, but it's anything of the form an x to the n plus an minus 1 times x to the n minus 1, all the way down to a1x plus a0. All of the a's can be any number, and n is a whole number. So let's look at an example of a polynomial function. So a polynomial function can be 7x to the fourth plus 2x cubed minus 9x plus 1. There are a few things we can define with a polynomial function. The leading term is the term in the polynomial with the highest exponent on a variable. For this particular polynomial that I have, my exponents are 4, 3, 1, and 0. For just a constant, a number like 1, the exponent is 0. Out of those numbers, 4 is the largest. So my leading term would be 7 times x to the fourth. Next is the leading coefficient. This is the coefficient of the leading term. So for this polynomial, we've already defined the leading term to be 7x to the fourth. So the leading coefficient would be the 7 that is out front in that term. Finally, the degree of a polynomial is the exponent on the leading term. This is going to be the largest exponent on a variable. So in this particular polynomial, 4 would be my degree. As another example, I have several functions here, and I want to find the leading term, the leading coefficient, and the degree of each of these. For the first one, 8x to the fourth minus 6x squared plus 7. The term with the largest exponent is 8x to the fourth. That would make this my leading term. The coefficient of that is an 8, so that would be the leading coefficient, and then the exponent of that term is 4. So that particular polynomial has a degree of 4. Next up, f of x equal to 3x minus 4. There's only one variable term in this one, which is the 3x. So 3x is my leading term. The number out front would be 3, which means my leading coefficient is 3, and since I do have an x with no exponent, that tells me that the degree is 1. Next up, 2x cubed minus 5x to the fourth. The term with the largest exponent is the term with the 4 as the exponent. This means my leading term is negative 5x to the fourth. The coefficient would be the number out front, which is negative 5, and then the degree would be the exponent, which is 4. Finally, we have 4x squared minus 1. The largest exponent here is on the 4x squared term. This tells me that my leading term is 4x squared. The number out front is the coefficient, which tells me that the leading coefficient is 4, and then the degree is the exponent, which tells me that the degree of this particular polynomial is 2.